So for number 1, part A, you're trying to leave your opponent with the licorice because you do not like licorice. So I have my drawing up at the top of the paper. I said, I will choose to go first. I will take 4 starbursts. This leaves 5 groups of 5 and 1 licorice. We're leaving the licorice separate because we do not want it. So that leaves us to focus on the 25 remaining starbursts. The lowest sum that is always possible is 6. Whenever my opponent chooses, we will take 6 minus x, x being what they chose. Doing this repeatedly should leave them the licorice. Now in part B, we do want the licorice, so we will include it into our groups. So I will go first. I will choose 5. This leaves 5 even groups of 5. Every turn after the first, I will take 6 minus x. X is what my opponent chooses. If this is done each turn, it should allow me to choose enough candies to have the licorice. Number 2, we were asked to compare a place value system and an additive numeration system. So the place value system, it has symbols used over and over, but their placement matters. An additive numeration system has different symbols for each value, and they mean different things. So in the Hindu Arabic system, it's a place value system because we have the same numbers, 0 through 10, but placement matters. So if you take the number 4, if it's in the ones place, it's 4, but if it's in the tens place, it means 40. And the same goes for Babylonian, Mayan, and Aztec numeration systems, but they have different bases than the Hindu Arabic system. For the Roman numeration system, and like Roman numerals, it is an additive system. This is because each symbol has a different value no matter the placement. The number we were given for number 3 is 2,475, and we were to use Babylonian, Mayan, Roman, and Aztec numeration systems. For Babylonian, there's 3 different sections. So there's the first section, which is how many 3600s, the second section, which is how many 60s, and the last section, which is the remainder. So since there are no 3600s in 2,475, there will be 0. So we immediately start at the second section, which is the second section, which in 2,475 there are 41 60s. So this is a symbol of 10, so there's 4 10s and then the 1. This is the remainder, so you have 15 as your remainder. This is a symbol of 10 and then 5 1s. Move on to the Mayan numeration system and its representation of 2,475. So it's divided into 3 sections. The top section shows 6, which is the dot over this line. That is because of how many 20s are in it. So we use 6. It's a base 20 system, and to get the top part, for 2,400, we know it as 6 times 20 squared. So that's how you get the top part. The middle part, there's 3 dots. Each dot represents a 20. This is because there are 3 20s in 75. Now this leaves 15. So now we account for 2,460. This is 2,400, and this is 60. Now we have 15 to get the 2,475 because each line represents 5. So that is the Mayan numeration system representation, 2,475. Now we move on to Roman. So each M represents 1,000. So this is 1,000, 2,000. Now C represents 100 and D represents 500. Now, we represent 400 by showing C before D because we are a 100 before 500. So now we are at 2,400. Then L shows 50. Each X is a 10, so now it's 2,470, and then we have our leftover 5 to make it 2,475. We move on to Aztec numeration system. So all 6 of these, each and every one of them means 400. So 6 times 400, 6 times 400 is 2,400. Then we have 75 to go. So each of these symbols, like flag-looking things, represent a 20. So there's 3 20s and 75, and that leaves 15. The diamond represents 10, and then this represents 5. So now that gives you 2,475, and that shows you all the numeration systems for given 2,475. So question 4 is Egyptian form of doubling. And the question was 27 times 54. So we want to keep one side, and then, so we're keeping the 54. And we want to eliminate this other side and start at 1. Now, it's called doubling because we're going to double each side. So we're starting the first one at 1, and we're starting this at 54. And we will continue to double. Now, we'll double until it gets to a point to where the side that started with 1, if you double it anymore and it goes over your original number, you can't do it anymore. So we're done doubling. So our highest number on this side is 864, and our highest number on this side is 16. Then we have to add up the numbers on the left side to get to 27. So the numbers that do that are 16, 8, 2, and 1. We use their corresponding quantities on the right side. So that would be for 1, 54, for 2, 108, for 8, 432, and for 16, 864. This gives us our total of 1,458, and that would be the exact same as if you multiplied just 27 times 54. Question 5. We are showing the Egyptian form of dividing and how to split 4 loaves of bread evenly among 7 people. So here we have our 4 loaves of bread, and each person is going to get a half. Now this leaves a half open, and what we can do to evenly divide it amongst the 7 people is you split it into sevenths. So a seventh times a half equals 1/14. So if we do a half plus 1/14 to show what each person got, that's 4 sevens. That's how you divide among the bread amongst the 7 people. Now in Egyptian hieroglyphs, this symbol means a half. That's how you show your half. Now this is to show the fraction. So it's 1 over. That's what this is. Now this symbol means 10, and each one of these is 1s, therefore 1/14. Now if we were to show this another way, we could split 4 loaves into thirds and then further into sixths. So that's how we get the 1/3 plus 1/6. And person 1 gets these 2, person 2 these 2, person 3 these 2, and so on until we get to here where each person will now just get 1, and this leaves a half open, a whole half of this loaf of bread. Now we can split that into sevenths even further, and again a 7 times a half is 1/14. So 1/3 plus 1/6 plus 1/14 equals 4 sevens. That's how you can divide it another way. Now to show the hieroglyphs for 1/3, it's the 1 over and then 3 lines. Same thing with the 6, it's 1 over 6 lines. Each individual line is 1. Now this is the same symbol as shown above. It's a 1 over. My circle is a little big, I apologize. But we have the symbol that means 10 and then the 4 1s. And that is how you get 4 sevens in 2 different ways, showing Egyptian hieroglyphs and Egyptian form of dividing.